Hi, this is Rich Evans, and this video is about piecewise-defined functions, which are functions that are defined in two or more parts. As you can see in number 1, if x is less than or equal to 0, the y value is going to be found using the formula 2x minus 1. However, if x is greater than 0, we'll use the formula x plus 3 to find the y value. So, in this first case, for f of negative 3, the x is the number inside parentheses, and that's negative 3. And since negative 3 is less than or equal to 0, we'll use this top equation, and we'll take 2 times negative 3 minus 1. So this will be 2 times negative 3 minus 1, which is negative 6, minus 1, which is negative 7. In part B, the x value is 0, and since 0 is less than or equal to 0, we'll still use the top equation. So we'll take 2 times 0 minus 1, which is 0 minus 1, which is negative 1. And in this part C, the x value is 4, and 4 is greater than 0. So we use the second equation, and we'll take 4 plus 3, which equals 7. Now to graph this function, we will need to kind of piece the two graphs together. We really have two different graphs, both of which are straight lines. In one case, the top equation is y equals 2x minus 1. So that's one graph that we're going to make. I'm going to write that one down separately. So y equals 2x minus 1. Now that, and the other one is y equals x plus 3. I'll write that down over here. Both of those are straight lines because they're in the form y equals mx plus b. So to graph them, we just need to know what the y-intercept is and the slope is. Now in this first graph, the y-intercept would be negative 1, and the slope is 2. So we would graph that by plotting the y-intercept at negative 1, and then since the slope is 2, you'd go up 2 and over 1 a bunch of times. Or you could go down 2 and back 1. So the line would look like this. And generally, that's how you would graph that line. But in this case, since we're only going to use the portion of that line when x is less than or equal to 0, we want to eliminate the part of that that has positive x values. So I'm going to eliminate this side. I'm going to erase it, the side that has positive x values, and just keep the part that has x less than or equal to 0, which would be this part right here. Now for this other line, the y-intercept is 3 and the slope would be 1. So we'd graph it by going up to a y-intercept of 3. And since the slope is 1, we'd go up 1 and over 1. And we want to include the portion of that where x is greater than 0. So that's the part that's on the right-hand side here. Now the point right where x equals 0, we wouldn't want to include that because 0 is not greater than 0. So we're going to leave an open circle right there to show that point is not included. Okay, this point down here is included, so you'd make a solid dot. Now this second example is similar to the first one, except there's 3 parts instead of just 2. So I've already filled out the table here, but let's just go through it really quickly. When x is negative 4, since negative 4 is less than negative 2, you use this top equation and take 3 minus negative 4, which is 7. When x is negative 3, you still use the top equation. When x becomes -2, you switch over to using the middle equation because -2 falls in this middle set. And the same thing with 0 and 1. And then when x is 2 and 3, they fall into the third case, so you use the third equation. So really, to kind of summarize there, these first two x values in the table, we used the top equation, and then for the next three we used the middle equation, and then for the last two we used the bottom equation. Now to graph this function, we have to graph these three equations. They're all straight lines because they're all in the form y equals mx plus b. So there's going to be basically three different straight lines pieced together. So we'll start with the top one, y equals 3 minus x. Let's write that down here. Let's see, y equals 3 minus x. I'm going to rewrite that as negative x plus 3. So it's in the form y equals mx plus b form. M would actually be -1. So in that case, the y-intercept is 3, and the slope is -1. So we'd plot 3 as the y-intercept, and then -1 means down 1 and over 1. So let me just put a few points. Or going the other direction, you'd go up and back 1. And then you would graph those. Now normally you would just want to graph the whole line, but in this case we want the portion that's just less than -2, meaning to the left of -2 on the x-axis. So here's -2 on the x-axis, and we want the part that's to the left of that. So we'll erase all the part that we don't want. And when x is -2, that's not included, so that would leave us with an open circle there at -2. And that would be the first part of the graph. And then for the middle part, for between -2 and 2 on the x-axis, we just want the line y equals x. Okay, and so that's going to include -2 but not include 2. So y equals x, to plot some points there, you'd have 0, 0, 1, 1, 2, 2, but that last one wouldn't be included, and then -1, -1, -2, -2, that one would be included, so it would look like that. And then for the third one, we have the line y equals x plus 1. We want the part of that that's to the right of 2 on the x-axis. So if we graph the entire thing first, we can erase the part we don't want if we're careful. So the whole line would have a y-intercept of 1 and a slope of 1. So it would start here on the y-axis at 1, and then it would go up 1 and over 1. From there. But we only want to keep the part of that that's to the right of x equals 2. So we'll keep from this point right here to the right, and I'll erase the points that we don't want. And so that would be the graph of our function. In this next problem, we're given the graph and we want to find the equation. So you see there's two parts here. So we know our equation is going to be y equals, and then there's going to be two separate parts. we're going to have one part if x is less than 0, because you see this left part of the line includes the negative x values. And then we're going to have another equation if x is greater than or equal to 0. So as far as the equation, since they're both lines, we know they'll be of the form y equals mx plus b. We just have to know what the y-intercept is and what the slope is. And it's pretty easy to see where the y-intercept is. And in the line on the left, it's 3 and 0 for the one on the right. The slopes are a little trickier to figure out. I've put some dotted lines in to help me here. It turns out the slope of the line on the left is -2. So the equation would be y equals -2x plus 3. And the one on the right has a slope of -3. So the equation would be y equals -3x plus 0, or just y equals -3x. This next problem is the same type of problem. We're given the graph and has to find the equation. This one has 3 different pieces to it though. You can see there's 3 different lines here. There's this one here, and then there's the one that goes horizontal, and then there's this one here. So we're going to have 3 different parts. So we're going to have y equals, and then a big set of brackets. There's going to be 3 different equations here. It looks like the changes happen at x equals -1 and at x equals +1. So the first case is going to include if x is less than 1, and then the second case is if x is between -1 and +1. Doesn't include the +1 though, because there's an open circle there. And then the last case is if x is greater than 1. And that doesn't include the 1 either, because there's an open circle on that part also. So again, all we need to do, since these are straight lines, they're going to be in the form y equals mx plus b. M is the slope, b is the y-intercept. So we just have to be able to tell what the slope and the y-intercept are. And it turns out, if we start at the one on the far left, the slope is 1. And the y-intercept, if you extended that up there, if you extended this line up, it will cross at 3. So the y-intercept would be 3 and the slope is 1. So the equation is y equals x plus 3. The line in the middle, the horizontal one, since it's horizontal, it's just y equals 2. It's just a constant. And then for the one on the right, the slope of this is 1. And if you extend this down, you would see that it would cross the y-axis at -1. So the y-intercept would be -1. So the equation would be y equals x plus -1, or -1. Okay, I just noticed in this first equation right here, I accidentally put an extra y equals there. So I can't erase it now, but I'm just going to cross that part out because you wouldn't need that there because we already have the y equals on over here on this side. Okay, so that would be our function in 3 parts. Now problem number 5 is an application problem, and it says a local gas station is charging $2.80 per gallon of gas. However, the gas station has a promotion where anyone who buys more than 12 gallons of gas only has to pay $2.70 per gallon. So how much will it cost to buy 8 gallons of gas? Well, since 8 gallons is less than 12 gallons, they'll have to pay $2.80 per gallon. So the answer would be $2.80 times 8 gallons. So 280 times 8, which is $22.40. For 10 gallons of gas, well, they're still going to have to pay $2.80 per gallon. So 280 times 10 gallons, which is $28. Right on the nose. Now for 13 gallons of gas, since 13 is over 12, they're going to get a reduced rate. So it's only $2.70 per gallon times 13 gallons. And that comes out to be $35.10. And for 15 gallons, again, they still get the reduced rate of $2.70 per gallon. Multiply that times 15 gallons. And the cost would be $40.50. So you can see here the formula you're using to calculate the cost depends on how many gallons they buy. So in part B, we have to write the function for the total cost as a function of the number of gallons purchased. So that would be C of G equals, we're going to need two separate rules. The first rule will be if the number of gallons, that's G, is less than or equal to 12. And the second rule will be if the number of gallons is more than 12. Okay, so if the gallons are less than 12, then the cost is going to be 280 times G. And if the number of gallons is greater than 12, you're going to do 270 times G. Now to sketch this, we're going to have, again, two straight lines, which will change when G equals 12. Now we've scaled my axes so that the horizontal axis represents the number of gallons of gas. And I chose to let each square represent 2. So that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 gallons. Those are gallons. And this is the cost in dollars going up. So $0, each square is $5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Now notice the rule changes when G is 12. So I'm going to put a dotted line right where G is 12. We should find we have one line on the left of that dotted line and another one on the right. Now if 0 gallons are purchased, it costs $0. So you're going to have the origin as your left point here. And if 12 gallons are purchased, then the cost would be $2.80 times 12, which is $33.60. So it would be right about here. And you'd have a straight line connecting the two. Now for the other side, when the number of gallons would be 12, 270 times 12 is 3240, so it would be just a tad bit under that one. And it would go up from there. For example, when it's 20 gallons, it'd be $54. So about up here. So it's going to look something like this. Problem number 6 is another application. It says your favorite dog groomer charges according to your dog's weight. If the dog is 15 pounds or under, the groomer charges $35. If your dog is between 15 and 40 pounds, she charges $40. And if your dog is over 40 pounds, she charges $40 plus an additional $2 for each pound. So how much will it cost to groom your dog if your dog weighs 10 pounds? Well, since 10 pounds is under 15 pounds, the groomer is going to charge $35 for that. 20 pounds? Well, 20 pounds is between 15 and 40, so she's going to charge $40. 30 pounds, still between 15 and 40, so it's going to be $40. 40 pounds is still between 15 and 40, so it's going to charge $40. Now 50 pounds, this gets a little trickier. That's more than 40. So the charge is going to be $40 plus an additional $2 for each extra pound. So it's going to be $2 for that extra 10 pounds that are over 40. So it'd be 40 plus 20, so it'd be $60. And for 60 pounds, well, it's going to be $40 plus for every pound over 40, it's an additional $2. And there's 20 pounds in addition to the 40, so it'd be 2 times 20. So that would be 40 plus 40, which would be $80. Now the piecewise function here is going to need 3 parts. So we're going to have y equals 3 different equations. We're going to need one equation if the weight of the dog is 15 pounds or under. So we'll call that x less than or equal to 15. We're going to need another equation if x is between 15 and 40. So 15 less than x and less than or equal to 40. And then we're going to need a third equation if the weight is over 40. So if x is greater than 40. Now let's do them one at a time. If the weight is less than 15, then the groomer charges $35. So the y value is just going to equal 35 in that case. It's a flat rate, so it's just a constant. For the second case, if the weight is between 15 and 40 pounds, she charges $40. So again, that's just another constant, 40. The last one's the kind of tricky one. If x is greater than 40, she's going to charge $40 plus an additional $2 for every pound over 40. Now you can't just use an x here because x represents the total pounds, not just the pounds over the 40. So if x is the total pounds, you take x minus 40 would give you the additional number of pounds above and beyond the 40 pounds. So for example, if the dog weighed 60 pounds, then x would be 60. 60 minus 40 would be 20, which is exactly what we used right here. Now we want to graph this function. So to graph the function, first of all we need to scale our axes. So I've scaled my horizontal axis where each square represents 5 pounds. That's x, and that's the weight. And I've scaled my vertical axis the same way, where each square represents 5, but this time it's $5. So that represents the total cost. Now notice, where are the changes going to happen? There are going to be 3 different lines pieced together, but the changes are going to happen at x equals 15. So changes from the first rule to the second rule. and then at x equals 40, it changes from the second rule to the third rule. So I'm going to put dotted lines in there again at those two places. So at 15, it's right here, we're going to have a change. And then at 40, there's going to be another change. Just so we kind of can expect where the changes are going to be. Now, for x less than 15, that's in this area right here, the y value is just going to be 35. Since that's a constant, that's going to be a horizontal line. So it's going to be 35 from here right to there. And then for the next one, when x is between 15 and 40, which represents this range here, the cost is just going to be 40. So that's another constant. So it's going to be 40. I mean open circle at this end because it's not included, and it's closed at this end because it is included. Now for the last one. Now one strategy is to plot 2 points. Figure out what this third rule would be if x was 40. So if x was 40, you'd have 40 minus 40, so that part would be 0. And 2 times 0 is still 0, so it would just be 40. So the point really would be right on top of this other point, right here. Okay, right here. And then to do another one, like when x is 60, 60 minus 40 is 20, and 2 times 20 is 40, 40 plus 40 is 80. So when x is 60, you would have 80, which would be actually all the way up here. Slightly off my picture because that top line is 75. So what it's going to do is it's going to start where the other one leaves off, this one starts, and it goes up like that.